number which is obtained by the solution of a Schrödinger equation and depicts the address of the electron inside the atom in a codified manner. Likewise, the intelligence personnel or raw personnel are not addressed by their name, rather they are addressed by their code number. Similarly, the address of the electron inside the atom is defined or described by the number which is the solution of a Schrödinger equation called quantum number. Let us give a detailed concept of the quantum number. Suppose a student is reading in Bhadrak College, Bhadrak, and residing second hostel, and residing room number 10 and seat number 5. Suppose we want to drop a letter in favor of the student. Then we have to write Bhadrak College, Bhadrak. If you don't mention his name at all, first we have to write Bhadrak College, Bhadrak. A letter in Odisha from any post bag will come from Bhadrak. Then in Bhadrak there are so many hostels, mess, etc. Then if we mention the second hostel, then confidently the letter will reach in the second hostel. In second hostel there are so many rooms. If we mention the room number 10, then letter will reach in the room number 10. And in a room there are so many beds. If we mention the seat number 5, then postman will drop the letter in the seat number 5. Thus, the student staying in seat number 5 will get the letter instead of mentioning his name, father's name, roll number, class, etc. Thus, the 4 numbers are required to describe the address of the student in a codified manner. That is Bhadrak College, Bhadrak, second hostel, room number and seat number. 4 numbers are required to describe the address of a student. Similarly, there are 4 quantum numbers to describe the address of the electron inside the atom, such as principal quantum number, azimuthal quantum number, magnetic quantum number, and last one is spin quantum number. Your principal quantum number is compared with the Bhadrak College, Bhadrak. Azimuthal quantum number is compared with the second hostel. Magnetic quantum number is compared with your room number. Spin quantum number is compared with your seat number. Therefore, the 4 numbers are comparable with 4 quantum numbers. The 4 quantum numbers describe completely the address of a electron inside the atom in a codified manner. The principal quantum number you can represent in a Venn diagram plus quantum number. The universal set is the principal quantum number. Azimuthal quantum number is the subset of principal quantum number. Magnetic quantum number is the subset of azimuthal quantum number, and spin quantum number is the subset of your magnetic quantum number. Similarly, universal you can present in a Venn diagram in the light of set theory, and these 4 quantum numbers are arranged in this manner. That is, the principal quantum number is universal set. Azimuthal is a subset of principal quantum number. Magnetic quantum number is a subset of azimuthal quantum number. Spin quantum number is a subset of magnetic quantum number. This is the arrangement of 4 quantum numbers in the atom. Let us discuss in details principal quantum number. The principal quantum number gives the position of the electron in a shell. This gives the position of the electron in a shell, and it is represented by small n. The principal quantum number is represented by small n. N1 implies that electron is present in K cell. N is equal to implies that electron is present in L cell. n is equal to 3 implies that electron is present in M cell, n is equal to 4 implies that electron in M cell, and so on. There are 7 quantum numbers representing the 7 cells of an atom, 7 cells of the atom. Thus, the principle gives the position of electron in a cell by means of a simple number. Without mentioning cell name, we are addressing the electron by a simple number such as 1, 2, 3, 4, etc. This is the code number. Energy of the cell is given by 31.36 kilocalorie by n square by small n square minus 313.6 kilocalorie by n square, where n is equal to number of orbit. For first orbit, n is equal to 1, second orbit, n is equal to 2, third orbit, n is equal to 3, and so on. That means as the number of cell increases, minus value decreases, and hence energy of the cell increases. Energy of cell increases. That means we can write that the K cell is energy of the K cell is less than L cell, is less than M cell, is less than N cell, and so on. As the value of N increases gradually, the energy value also increases accordingly. Then this is the energy of any cell we can represent. The maximum number of electrons that can be present in a cell is equal to 2n square. 2n square, where n is small n, where n is equal to number of orbit. For first orbit, n is equal to 1, second orbit, n is equal to 2, third orbit, n is equal to 3, fourth orbit, n is equal to 4, and so on. Hence, the maximum number in K cell is 2, L cell 8, M cell 18, and so on. And so on. The electron will increase in the cell in this manner. Thus, the principal quantum number describes the position of the electron in a cell as well as energy of cell and energy ordered among different cells, as well as the electron carrying capacity of every cell. This is all about your principal quantum number. Principal quantum number. Let us discuss another quantum number, azimuthal quantum number. It gives the position of the electron in subcell and represented by small l. The azimuthal quantum number gives the position of the electron in a subcell is represented by small l. The value of L is calculated as following by using a very simple algebraic formula. Very simple algebraic formula. L is equal to 0 to from 0 to n minus 1. Value of L is equal to from 0 to n minus 1. From 0 to n minus 1. That is, L depends upon n, small n. When n changes, L changes. That means we can write mathematically L is the function of L. L is the function of n. That means azimuthal quantum number is a function of principal quantum number. The azimuthal quantum number is the function of principal quantum number. Let us calculate when n is equal to 1. When n is equal to 1. When a is equal to 1, that means K cell. When a is equal to means K cell, value of L is equal to 0. L is equal to 0. 1 minus 1 is equal to 0. When n is equal to 2, that means L cell, n is equal to 0, 1, because we have taken value of L is from 0 to n minus 1. First we have to write 0, then accordingly other numbers. 0 to the maximum number. When n is equal to 2, n is equal to 0, 1. When n is equal to 3, that is K, L, M cell, the value of n is equal to 0, 1, 2, 0, 1, 2. When n is equal to 4, that is N cell, the value of n is equal to 0, 1, 2, 3. 0, 1, 2, 3. Here, these are all code numbers. We know In mathematics, 0 means meaningless. It has no meaning. 0 means it has no meaning. But in our chemistry, especially in quantum number, the 0 has definite meaning. 0 has definite meaning because these numbers are code numbers. These numbers are code numbers, and specific number has specific meaning. That means L is equal to 0, it is S sub cell. L is equal to 1, P sub cell. L is equal to 2, D sub cell. L is equal to 3, F sub cell. F sub cell. These are 4 subcells in the atom. 4 subcells, namely S, P, D, F. S stands for sharp, P stands for principal, D stands for diffuse, F stands for fundamental. These are the full term explanation of 4 subcells of the cell in the atom.